Welcome back, guys. In today's video we are going to solve random problem from a random country, and we choose random country for this site, and I will click this and it will generate a random country, and then I will see this country on AUPS and try to find the functional equation from this country, and I will try to solve it on AUPS using LaTeX. And our country is Nigeria, so let's go to contests and where's Nigeria? Here. And I will try to find the functional equation if there is any. If there is not, then I will try to choose another country. There is nothing here. Nope. I mean, that doesn't count as a functional equation. I mean, not here. This is not like we want from rational numbers and not something random. Okay, maybe in the fourth round. Nope. Nope. Oh, there is. Okay, we have one. Let's copy this. Like this. And now we will try to solve this problem. And we have to find fx. Okay. Well, we can do like this. Okay, it's fine. Okay, first of all, I will try this. And we will get ff0 is equal to 0, which is nice. And I will also let f0 be some c, which implies that fc is equal to 0. So we have, and we know that there exists a number, for example c, such that fc is equal to 0. Also, let there exists a and b such that a is more than b, and fa is equal to fb. Now we are trying to prove injectivity, and if we subtract these two, we will get fx square plus fa minus fx square plus fb is equal to a minus b plus x times fx minus x times fx. So we have this equation. So this side, so these two are the same. X times fx minus x times fx is 0, and these two are the same because we know that fa is equal to fb. So we know that left hand side is equal to 0, which means that right hand side should be 0. Right hand side is equal to 0, and now this means that a minus b is equal to 0, which means that a should be equal to b, and this proves that f is injective. And now for the subjective part, let's put this. Maybe we don't need injectivity and subjectivity, but you know, it's always good to like put those. So we get ff y is equal to just y, and from here actually this means that f is in motion, and this also means that f is surjective because we can choose y equal to anything, and there exists a function such that f a is equal to y for every y. So we know that f is bijective. Okay, now since we have this, I will put, sorry, okay, I will try to do this, because we know that ffy is equal to y, so right here this will become y, and if we replace y with a y square, we get symmetric on this side, and if we replace x with a y and y with the x, we get we should get something good on the right hand side. So this is f x squared plus y is equal to f y plus x f x. And now let's replace y with the y square, and we will get f x square plus y square is equal to f y square plus x f x. Okay, and let's call this qxy. So let qxy is equal to fx square plus y square is equal to fy square plus x times fx. And now if we pick this, okay, so we will get fx square plus y square, which is same as qxy, is equal to fx square plus y times fy. Okay, so if we subtract these two, so subtract these, so we minus this. Okay, this implies that so fy square minus y times fy is equal to fx square minus x times fx. So this means that this difference should be constant, because it's true for every x and y. So we have fx square is equal to xfx plus c. Okay, and if we put actually this c is same as this, because if we put x equal to y, actually if we put x equal to 1, we get f1 is equal to f1 plus c, which implies that c is equal to 0, which is also f0, and we know that f0 is 0, and we also know that fx squared is equal to x times fx. What we can do here? We can replace x with a fx, and we will get fx square is equal to fx times f f fx, which is equal to x times fx, which we know that is equal to fx square. And since we know that f is injective, we get that fx square is equal to x square. So from here we have either fx is equal to x or fx is equal to minus x. Now we can try these answers, but yeah, let's check if fx works, because it's easy to check, but for the minus x we get f minus x squared plus y is equal to y minus x squared. So both answers work, and now we have to check if there exists if a is equal to a, and for every x in the real numbers, fx is equal to minus x. So okay, so there exists only one a such that fa is equal to a, and for every x in the real numbers except for a, let fx is equal to x minus x. Actually, let's do this because it will be simpler. So let's put this x and a. Let's try this. Implies f x squared minus a is equal to a plus x squared. Okay, and we know that x squared minus a is not equal to a for every x, because yeah, it's not true for every x, of course. I mean this here, if x squared minus a is not equal to a for every x, it's obvious. So we know that x squared minus a is not a, so if x squared minus a should be equal to x squared minus a. So x squared minus a plus no, is equal to a minus x squared, and this means that f this means that 2a no so we missed this. Okay, it's correct. So we get 2a is equal to 0, which means that a is equal to 0, and we know that f0 is 0, so this is not a problem for us because f0 is equal to 0, which is equal to minus 0. So with that being said, we have two answers. Fx is equal to fx is equal to x, or fx is equal to minus x. And this is our answer. Let's do this. Actually, it would be simpler if we do this. Okay, so we get fx is equal to modulo of x, and we are done solving this problem. If you want to see any of this content where I choose a random country and try to solve a problem for this country, which is functional equation, subscribe and comment down below that you like this video, or if you don't like this, why you don't like this, and something like that. So if you choose another country, it would be, wow, I don't know any problem for this country. Okay, anyways, goodbye everyone.